guys, in this video we're going to be putting together a 307 Chevy. Now there's absolutely no reason to put together a 307 Chevrolet unless it's the original engine to your car and you just have to have it. Or if you want a 307, you've already got one. So it's going to cost you the same money to build a 307 as it would a 350 or more. Now the only reason it wouldn't cost you more is because you already have the 307 and you'd have to buy a 350. And older 350s are going for a little bit more than they used to. Still easy enough to find, but by the time you find one that is in good enough shape to be rebuilt, it's not already bored 60 over and it's, you know, it's got some life left in it, you're going to pay a couple $300 for a decent core, especially if it's a 4-bolt main. 307, if you don't already have one, you can get one of those probably for $50, maybe 100. This one I actually got in a car. I bought the whole car for $400, and it was something that the car is really rusty. I kept the engine. I mean, I've still got the car. It'll be in another video later. Anyway, the 307 cost more to build than a 350 because the pistons are more expensive. So if you're building a completely stock 350, it's going to cost you about $75 less because a 307 engine kit costs more because nobody wants them. Now the problem with the 307 is the small bore. It's got a 3.875 bore. This one's 30 over now, so it's a 3.905 bore. It's got a 327 stroke crank in it, which is 3.25 inch stroke. So there was never a factory performance engine at all. The compression was always dismal. I think at the most they had 200 horsepower, and that was gross horsepower ratings. And then once they went down, I think it went to 140 or something like that. But they're all 2-bolt mains. They all have pretty good blocks, pretty thick blocks. Some guys bore them out all the way to 4-inch and build 327s or 302s out of them. Now, the aftermarket does not support this at all. The only pistons available are cast flat top pistons. That's pretty much it, unless you order a custom set. Now, I wanted to run forged pistons so I could make some real power with it, but I thought I had it figured out. I was going to use LS pistons. Stock bore LS pistons are the same as 30 over 307 pistons. The pin size was the same. I was like, hey, I'll make the distance up in the rod, use a longer rod, and I'll be okay. Wrong. The pistons that we ordered ended up having valve reliefs way out of the place of normal Chevrolet valve reliefs on your conventional small blocks. So we decided we couldn't use those. Now that's a shame because they were nice pistons. It was going to give me a good metric ring package, plenty of options on rings. And so I decided to not use those and just go with stock cast replacement pistons. The problem there, they're flat tops. They've got a big chamfer around the edge, which kills compression, and it's got 5/64 ring package. Now, that'll be fine. Like I said, at the power level I'm going to have on this thing, I'm hoping for 350 horsepower, but these pistons are going to be just fine, not going to be a problem. Now the rods are Scat I-beam rods. They're 4340. They've got good bolts in there, and they're press fit. So, like I said, they're already on here. I had the whole assembly balanced, so not going to have any issues there. The crankshaft is the stock crankshaft out of that same engine. It was not turned. It was just polished. Everything looked in great shape. It was a fairly low mileage engine, so that helped out a bunch. Okay, so I had the block completely machined. I took it to the machine shop, and they cleaned it, magnafluxed it, checked everything, bored it, honed it, decked it. They didn't take a lot off the deck because I can still see the numbers on the front, at least off the front. But the deck is square. It's got a good hone job on it. It was torque plate honed, which is a little bit extra, not necessary on, you know, on something that's going to be pretty stock. But I wanted to get the most I could out of a 307, so I went ahead and paid for that. And we also had the rotating assembly balanced. Like I said, with all stock stuff, probably wasn't that necessary, but I want every little bit of performance I can get out of this thing without having to spend crazy money. Okay, when you get your block back from the machine shop, it really needs to be cleaned before you can assemble anything. Before I clean mine, I go through and I clean out all the bolt holes to make sure I'm not going to have any problems. I use a thread chaser. I don't use a tap because a tap can remove metal and you don't want to pull threads out of your head bolt holes. So I use a thread chaser. It's made for that. It's got some slots around the threads, lets debris come out. Clean all my bolt holes out real good, make sure they're all okay, and I don't have any issues. I do it on the main bolts, I do it on the head bolts, and then I spray and clean all the oil pan bolt holes, and the timing cover bolts, stuff like that, to make sure I'm not going to have any issues with that. Then I take the block out. I wash the entire thing the best I can. I spray like a degreaser type cleaner, Purple Power or something like that. Spray the whole block with it. Scrub everything the best I can. Rinse it really well with a lot of water. I spray through all my oil galleries in the bottom of the block. Between your main caps, and I got overspray on this block, I got to clean off. Between your main bearings and your cam bearings, I clean all those passages out all the way down. Between my oil filter hole and my main bearing or rear main, I clean all that out, make sure everything's good to go. And then I dry the block over and I wipe the cylinders only down with some WD-40 to make sure they don't flash rust, because here in Georgia, the humidity stays high enough, it'll rust in front of your eyes if you're standing there long enough. Okay, once I get the block cleaned, all my holes chased, the next thing I like to do is paint it, obviously. And then I take a lifter and I check all of my lifter bores and make sure my lifter will go down in all of the bores. I check every single one of them. And the reason I do that is because what you'll have is some machines or some machine shops use a shot blasting method to clean the block. And sometimes that will put a little chamfer or a little burr around the edge of the lifter bores, and you get your engine put together, go to stick a lifter in it, and they won't go because they didn't come back and clean them all out. Now, I've only had that happen one time, but once is enough when you've got the whole thing together and you got to take it all back apart to get a lifter in it. Let them hone the hole so you can put the lifters in it. Like I said, most machine shops, they know better. That's not an issue, but you know, it happened one time, you know, and it wasn't a big deal. I mean, it was a big deal. It sucked, but you know, the machine shop, you know, they took care of it. Okay, before I start to assemble anything, I'm going to check my ring gap and get all my rings gapped, because even though this is a 307, I will be adding some nitrous or boost to it. So maybe both. Probably not at the same time, but either way. All right, this is my number one cylinder. This is my number one piston. I'm going to get my second ring, and I'm going to make sure my top is up. I'm going to set this down in the hole. There we go. And I'm going to use my piston to kind of square it up. I have a piston squaring tool, but it won't fit anything less than a 4-inch bore. Now, since this is the second ring, you want a little more gap on your second ring. I'm going for 22 thousandths on my second ring. And for a street motor, that's a bit much. I really could go 21, I guess, and since it's a smaller bore, but I'm sure I'm nowhere near that at the moment. It's probably, yeah, it needs to go open a little bit. Okay, so I put it in my piston ring filer, filed it down a little bit, and then I took a little small fine hand file and made sure there wasn't a burr on the edge of the ring. And now I want to see, boom. All right, and it's dead on 21. So I'm gonna do my second rings at 21, my top ring at 19. Okay, so I got all the rings gapped. My top ring is gapped at 19 thousandths, and my second ring is gapped at 21 thousandths. Now, there are multipliers for different applications that you can use. You can look at Wiseco, Total Seal, all these different ring manufacturers pretty much agree. It's somewhere around 4 thousandths times the bore diameter for a street engine, all the way up to 7 thousandths for like a forced induction turbo race engine or whatever, multiplied times the bore. So anyway, I ended up with my bore times 5 thousandths and then 5.5 thousandths. I ended up with 19 and 21, so that's what we're going to go with, and that is for you know, nitrous application, nitrous and light boost application. So it'll be fine, because if I ever do spray this, it's not going to be with a lot. and it's still tight enough to where naturally aspirated, I'm not going to lose any cylinder pressure. So the first part I like to put in the block is the camshaft, and I'll tell you why I want to do that. The very first engine I ever put together, I put the crank in, I put all my rods and pistons in, and then I went to put the camshaft in, and one of the camshaft bearings was cocked sideways. And there was no saving it. I had to take it all back apart, take it back to the machine shop, and get them to straighten out the cam bearings. So now I always put the cam bearings, or the cam in first, make sure all my bearings are good to go, then I can flip it over and put my crank and rods and pistons in. Now, another reason to do that is if you're building a stroker motor, one of the issues of clearance is going to be with the rod bolts and the camshaft. And every time I put a rod and piston in on my crankshaft, I rotate it over to make sure nothing's going to touch. And if you put the camshaft in afterwards and one of the rod bolts is hitting the cam, you don't know which one it is. You've got to go through there and look and figure it out. If you have the camshaft in already, you put a rod and piston in, spin it over and it hits, you know it's that rod and piston. So that's just another little tip that I've picked up over the years. All right, so we're going to throw the camshaft in this thing now, then we're going to flip it over, get our bearings in, and get our crank set in it. Okay, so the camshaft we're putting in this 307 is a Camshaft 280H Magnum hydraulic flat tappet cam. Now that's a pretty large cam for a 307. I'm not too much worried about street manners. I think it'll be okay, but it's definitely a lot of cam for such a small engine. Now, they make a tool for a handle for putting these cams in, but I'll use my hands on it until I get close to the end, and then I put the timing gear on and grab that and stick it in. But if you can find one of the handles and pop for it, you know, it's not a bad idea to do it. You can also make your own. Now on a flat tappet cam, you want to make sure you get absolutely plenty of assembly lube. I'm putting some on the gear a little bit, but mostly on the lobes. You want to put plenty of lube on the cam lobes. And it comes with a little package of lube, but I like to use the stuff out of the bottle, which is Comp Cam stuff, so it better be good for their cams too. And then you want to put the cam in, try not to nick any of the cam bearings or knock them sideways. And then once you get the first couple in, it'll hold the cam for you to put the rest of the cam lube on. And this stuff sticks pretty good. To everything. So then what I do, I take the cam gear from the timing kit, put it on the alignment dial, put one bolt in it, and then I can use that as a handle to put the cam the rest of the way in. And there we go. Okay, we're going to start putting the main bearings in the block side. And the main bearings will be marked upper and lower. Don't forget that when the block's upside down, the bottom is upper. And then you double check. I always start with the rear main. It says upper. Put that in place. And I go through each one of the mains and make sure it says upper. And I put those in. Okay, so I went through the same process of cleaning the crank as I did the block. I cleaned out all the oil galleries, made sure the whole thing was nice and clean. I'm going to set this in there now. I'm not putting any lube on the bearings because I'm going to check clearance with plastic gauge, and it needs to be dry to do that. So you want to very carefully set it down in there. and let it sit. And then we're going to get some plastic gauge out, and I'm going to show you how to use that. Alright, so you want to take a small piece of plastic gauge. So you take your plastic gauge, okay, now you take your main cap, you set it down, make sure you don't rotate anything. Now I put a little bit of oil under the head of the bolt here, and I oiled the bolts up. And the factory specs on this is 70 foot-pounds. So I'm going to go to about 40 first and then go all the way to 70. Alright, now we want to back them off. And now I can see my plastic gauge on there, and they've got millimeters on one side and thousandths of an inch on the other. So now I want to hold my strip up and see where I'm at. So I'm right between 2 thousandths and 3 thousandths. 3 thousandths, it's too wide for that, and 2 thousandths, it's just not wide enough for it. So I'm probably right around 2.5 thousandths. So I'm going to go to each main journal and check that now, and then I'll do the same thing with the rods when I get ready to do that. Okay, so I'm going to install my rear main seal before I put my crank back in. And I'll leave the seal, good thing to do is leave it cocked sideways like that. Make sure you get it in there right, the instructions will tell you how. Then I take my main cap. And I do the same thing with it, making sure my field's facing the same direction. And make sure I've got the same amount sticking out. I'm going to put a little dab of RTV. And there. Put a little bit of oil on the seal. And then set the crankshaft in place. Now I want to take my main cap on the back. Go ahead and set it in place. And then put all my mains on. And the machine shop stamped all of my mains with numbers so that I would know which ones were which. And they've got arrows on them pointing towards the front so you know which way to put them. Okay, I used my impact to go ahead and just kind of zip them on down kind of quick, but I didn't use that to put any real torque to them. So now I'm going to torque them all to 70 in 2 steps. So I'm going to go to 40 first, and I'm just going to watch it instead of setting it. Nice thing about a digital wrench, you can watch it and know how close you're getting. Now we're going up to 70. All right. There we go. Okay, now that I have the crankshaft installed, before I start putting the rods and pistons in, I want to go ahead and get my timing set on, get my cam lined up with my crank where it needs to be. That way I can rotate everything over and not have to worry about any of the rods. In this motor, I'm not worried about the rods hitting the cam, but it's just practice. So I'm going to go ahead and put my timing gear on and get my... and I'm not going to degree the cam. Probably should. Be better if I did. But I'm not going to. It's a good idea, right? I'm really not hitting it that hard. Those of y'all worried about my thrust bearing, I'm sure it's okay. Alright, and I'm installing this straight up. I'm not using, it's got a 4 degrees advanced and a 4 degrees retarded. I'm not using either one of those. So, alright. Now I want to see where I'm going to be here. Roughly right there. Get my marks lined up. And if you're putting a double roller on a small block Chevy, it's a real good idea to make sure that your machine shop clearance to that boss right there where the oil gallery is, so it won't rub on the back of the chain. Okay. Chain on here. Already got my bolts. I've got some blue Loctite on them. All right. Now I'm going to spin this over, and then I'm going to check and make sure my marks line back up again. And it takes 2 whole revelations. It takes 2 whole revolutions. Revelations is a whole different conversation. All right. It takes 2 whole revolutions for it to line back up. And that was the second one right there. There we go. Okay, so I spun it around, it lined back up, we're good. This is actually top dead center on the number 6 piston, not the number 1. But, so you won't be at number 1 if you put the harmonic balancer on here. On the on number 1 cylinder, you'll be at top dead center on number 6. But anyway, good enough for now. Let's start putting some, I'm going to torque these real quick. I think it's 35 foot-pounds. I'll have to look at my ARP thing and see. But anyway, I want to torque these real quick, and then I'm going to start putting rods and pistons in. Alright, I'm putting a wooden handle between the edge of the block, or wooden hammer handle between the edge of the block and the rod journal on the crank. And I got these at 20 foot-pounds, which is what factory supposed to be, and I got thread locker on them. So there we go. Okay, now I'm going to start putting my piston rings on. I've already cleaned everything here, make sure it's good. Put your expansion ring on first. Then you get your bottom support ring on. And you get your top support ring on. And then you make sure you put your gaps on your top and bottom support rings where the instructions tell you to. Now this is piston number 1, and I've got my rings still in the bores from where I gapped my rings earlier. What I'm going to do is I've got my second rings on top, and then the top rings down below that. That way I can take the second ring out, put it on, take the top ring out, put it on. I've got my number 1 rod and piston here. I'm going to take my second ring out, make sure my dot is pointed up. And now it's installed. And I'm going to do the same for my top ring. Make sure you got the instructions ready on how the rings need to sit as far as what kind of marking gets them towards the top. Alright, now I'm going to do all the pistons like that, then I'm going to start dropping pistons in the holes. Okay, I'm going to put my number 2 piston in. I've already got the number 1 piston in. I want to make sure I didn't have any issues with my ring compressor I'm using. That went in okay. I've got my crank all the way down away from my rod so that when my rod comes down I'll have the most room. Keep hitting it. I got my old-fashioned ring compressor on the piston. I do not have a tapered ring compressor for this size. Make sure I got my notch on the piston pointing in the right direction. These pistons can go either way, but the way the rod bearing chamfer is set up, you have to have it in the right spot. When the machine shop puts the pistons on the rods, they put the notch towards the right side so that your chamfer is correct. Alright. I think I'm okay right there. Make sure I'm out of the way of the crank. Alright. Went in easy enough. Now we're going to flip it over. I've already got my bearing in the rod. Put a little bit of lube on the bearing. And I'm going to guide my rod bolts so they don't hit anything on the crank. Okay, so I went ahead and put the other 6 rods and pistons in. I turned the engine over every time I put one in to make sure nothing was hitting. Even though this isn't a stroker motor, that's usually when you have that problem. It's a habit, I like to do it. Make sure nothing's binding up for some weird reason. Now, crank's in, cam's in, timing chain and gears on. Got all 8 rods and pistons in. Got our rod bolts torqued down to where they need to be. So now what we need to do is we need to verify top dead center on number 1 with our balancer mark to make sure that when we go to set the timing on this thing, we're not having a bunch of problems because the timing is actually inaccurate. Okay, so when it comes to putting together a bunch of parts that you've never had together before, it's can be kind of a challenge. Now, if you've taken one engine apart and you're putting that exact same engine back together with all the parts, it's probably not going to be this big of a deal. But one thing you want to make sure of is that you're at top dead center when your balancer says you're at top dead center, because that's the timing mark you go by when you're setting your timing. Now, on Chevrolet engines, there's different sizes of balancers. You got a 6 3/4, you've got an 8-inch. Well, there's also different timing marks. Some of them had the timing mark welded to the timing cover right in the middle of it, and then other ones have the timing mark bolted to the side. Well, there's also different sizes of those. These are different lengths for different size balancers. This balancer, if you put it on number 1 and put it on here, your timing mark is almost straight up. Well, that's going to be one of the kind of covers that has the timing mark welded to the timing cover. So I can't use that on this engine because I don't want to put one of those covers on there. I don't want to find one or whatever. So I'm going to take that off, and we're going to be putting on a 6 3/4 balancer that I've had for a long time laying around. It's a good balancer. It's a stock balancer, but for this 307 it'll be fine. Now the 283s and 307 came with a smaller, skinnier balancer. There's nothing wrong with putting a heavier balancer on there, but you know what it came with is the smaller one. So I'm going to figure out which one of these I need before I put my timing. I'm going to figure out which one of these I need before I put my timing cover on. So I'm going to put this on, and then I'm going to take and figure out which one of these markers is going to be the right one. Now see, this is for like a 7-inch balancer, 7.5, or whatever other size it is, because it's too far away. And 0 looks like it's pretty close, and I'll show you how I found 0 in just a second. This one, there we go. See, it's real close to the balancer. You got room, but when it's on the 2 bolt holes it's supposed to be on, it's in the right spot. So this is the one I want to clean up and use. Okay, so when you've built an engine and you end up tuning it, you want your timing to be as accurate as possible. Well, if you don't verify where top dead center is in relation to your timing mark on your balancer that you're going to be using to adjust your timing with a timing light, then you're kind of going to be shooting in the dark a little bit. You might be accurate, you might not be. But the way to know is to get you a deck bridge. This one's magnetic. And I am going to figure out exactly where my piston stops moving, so I will know when it's at top dead center. Okay, what you want to do, I've got my bridge on here. I've got my micrometer being held right here. And then I've got the, 0 kind of doesn't matter at this point. I'll adjust it in a second. I've got my piston just below the top of the stroke, so it still can come up a little bit. And what I'm going to do is I'm going to see how far it will come up. And wherever the farthest it comes up is, I'm going to 0 that. Okay, it stopped coming up. It came all the way up to about 2 thousandths, so just past 0. I'm going to put my 0 mark on that. Now I can back it up just a little bit. It's still at 0. I can go forward just a little bit. It's still at 0. If I go just a little bit more, it starts backing off. If I go to the left just a little bit more, it starts backing off. So I want to go back to where I'm just at 0. Right there. And I know that's as far up as the piston is going to be. Now, you can do 2 things while you're doing this. You can check how far down in the hole your piston is by basically checking the deck height. Right here we're at 0. And if I come over here and check my deck height, we are at 34 thousandths. So my pistons are 34 thousandths in the hole. All right, so I know that much. Now I also want to do is I want to check my timing mark on my balancer and see if it's going to be right. Okay. Now I've got that on there, and this is bent a little bit out of the way. I'm going to bend it back down a little bit. So they make an adjustable one of these that you can adjust back and forth if this one's wrong. If you've got this type, you just kind of bend it till it's right, and then make sure you don't bend it again while you're putting everything back together for the last time, because it is kind of flimsy. So I'm going to take my balancer. I'm going to find my slot in my balancer. slide it on. I'm still at my 0 mark on my piston, so I know I'm all the way up on it, and I want to look and see where my 0 mark is on this timing tab. Okay, so this third little tooth right here on my timing mark is where the 0 is, and make sure your thing's on the square. I'm a little bit, there we go. I'm just about in the middle of the part below it, so I'm a degree off. What I'm going to do is I'm going to take this and tweak it just a little bit. So now that my tooth, where my 0 mark is dead on my timing mark. All right, so we've got plenty of clearance around that, so it's not going to be rubbing. We know we're on 0. We're still on 0 up here. So now we verify that our timing mark is at the top when the piston's on. Okay, so now that we verified where our top dead center mark is and our timing mark is correct with each other, had to tweak our timing tab a little bit, I can go ahead and take this all back apart, get this off. I can put my timing cover and gasket on, put my tab on, install my balancer, and then my oil pump and oil pan. Okay, so I cleaned my gasket surface real well. Now what I'm going to do is I'm going to put a little bit of RTV on here, just enough to give me a light coating for my gasket to stick. You don't need a ton on here. Okay, so my sealant's tacked up a little bit. I'm going to go ahead and put my gasket on. I said I don't have a lot of RTV on there, but I've got enough to keep the gasket in place, and I let it tack up for a few minutes. And then what I did was I took and I put cleaned my cover up, cleaned this out real good, made sure this was dry, and then I took my buffer and I buffed around the edge of it to try to knock some of the shine off of it. Same thing on the back. This is a used cover, but still wanted to hit it a little bit again to make sure everything was clean. I got some RTV on my seal. You always want to put a little RTV on your front seal. I'm going to take it and I'm going to get my front seal knocked in place, and then we're going to put this cover on to tighten it up. Okay, so I got my new seal in. Now I'm going to put a little bit of RTV on the back of this. Pretty much like I did with the front. I'm not putting a lot on it. Just enough to hold the gasket on and to make sure there's no little leaks. Of course, once I smear it on there, it looks like it's a lot more than it is, but it's not. Okay, so when you're installing a harmonic balancer, the only way you need to do that is with a harmonic balancer installing tool. If you don't use one of these, you're screwing up. And you're screwing up thrust clearance, which I didn't show you checking on this block, but it's okay. Now, you've basically got an adapter for different size engines in a harmonic balancer installer tool. This is the 7/16 20. You're going to go ahead and thread this in here, make sure it threads in with no problem. And you don't want to get that in. You don't want to get it in tight. You want to get it into where it's in the middle. You've got plenty of threads engaged, but you don't want it tight. It'll go pretty far ways in there. So you want to make sure it's engaged pretty good. Get your other part. Get your harmonic balancer. You want to make sure that you've got a little bit of lube on your balancer so that you don't mess your seal up dry. Put a little lube on there. You want to slide that over. Make sure it's pretty square. And then you want to take your, and then you want to tighten this down. Now you know that your other shaft is not tightened down hard, so you want to tighten that down into this one. And now everything will come loose pretty easy. You want to take your thrust washer and your nut, and And you still want to put a little of a lube on this because you don't want it going in completely dry. It'll could damage the threads. Some of these get on here pretty tight, so you want a little bit of lube on there. And you want to hold the end of this steel, tighten this up, it pushes your balancer on. Now it'll pretty much come to a dead stop when you get it all the way on. And really you should be real close to your timing mark depending on what kind you have. So I think we're good there. I'm going to take the pressure off of it. And now all of this should come out really, really easy. And now you didn't have to beat on it with a hammer. And this one's had plenty of hammer blows apparently, but you didn't have to beat on it with a hammer. It's fully seated and you're good to go. Okay, so I'm using a Mr. Gasket oil pan. It's a low profile oil pan. And it came with a pickup that goes on a regular pump. It won't fit a high volume, but it'll fit a regular pump. So I got my regular pump in now, and as always I am going to use a steel sleeve oil pump shaft. I'm not going to use the plastic sleeve. Anything other than stock, you want to get a steel sleeve and put on there. And I'm also using an ARP oil pump stud to hold this thing down. And I've already checked my clearance. What you want to do is you want to take a ruler, straight edge or something that has measurements on it. That would be a ruler, straight edge with measurements. And I'm at 7 3/4 here. And then I check the depth of my oil pan, and I'm right at 8 inches on the depth of the oil pan. So with the 1/4 inch clearance I've got there, plus a little bit for the gasket, I'll be right around 3/8 of an inch, which is where I want to be. Okay, before I put my oil pump on, I went ahead and rechecked all my main bolts and my rod bolts to make sure they were all torqued where they should be, and they were. So now I want to put my oil pan gasket on. I went ahead and cleaned and made sure my pan rail surfaces were clean. None of my assembly lube had dripped down, so I had, or some of my assembly lube had dripped down, so I had to get that off. So now I'm going to put my rear pan seal and my front pan seal on. I'm going to set this in place. Kind of see how that fits. I'm going to get a little bit of RTV smeared in the channel here. Put a little dollop in each corner. I'm going to put that in there and I'm going to let it get kind of tacky. I'm going to go around where my pan gasket goes and leave a thin layer of RTV there. And I'm also going to put some on the front timing cover lip. Okay, now I'm going to put my oil pan gasket down on my dipstick side. And I'm going to make sure that my little ears go under where the front and rear lip seals are. They go under the rubber seals. Make sure my bolt holes are lined up. Had my RTV got plenty tacky while it was sitting there. And my timing cover seal. Okay, got my oil pan ready to set on there. And you want to go easy with the RTV on the front and rear. You want to make enough where it'll seal. You want to put enough on where it'll seal. But if you go too crazy, you're going to end up with RTV coming loose and clogging up your gotta get the pickup past the baffle. There we go. you have RTV come loose and get in your oil pump screen and stop it up. And then you're going to have an oil pressure problem. So we got the oil pan on, now we flip it over. Start putting the heads on. Okay, so these are the heads we're using. These are 305 HO heads. They are the 416 casting number. They have 50 ACC chambers, which should help build some compression. We've got 184 exhaust valves, 184 intake valves, and 150 exhaust valves. Now what's been done to these heads? All right, so I already had these heads, been saving them for a while. I had new valves put in them because the old valves were junk. And then I had a competition valve job done on them, so they did what they call a bowl hog, which is where they go in and put it on a valve machine. They're stock replacement valves, so they're not back cut or I'm sorry, they're not undercut stems or swirl polished or any of that, but they're good valves. I had them surfaced just lightly, so I'll have probably about 56 cc chambers. I did not have screw and studs put in them. I was going to, and then decided I'm probably not going to run these heads for long. I really want this thing to make some decent power. So what I'm going to end up doing is I'm going to put the 175 trick flow heads on there that have the 194 valves. So it'll get some aluminum heads with 194 valves, so I won't have any problems with my valves coming close to my cylinder wall. The springs and retainers came with the Cam's cam kit that I bought. That came with the timing chain, the cam, the lifters, the springs, and the retainers. It's the 480, 280 cam, 280H cam. It's got 280 duration, 480 on the lift. Now, the gaskets. I'm using Harmonic gaskets. This is a very expensive gasket compared to a stock gasket. These are about $80 a piece. The reason I'm using these is because the compressed height is about 28 thousandths, and it's got a 4.030 bore. Now, on a 350, these wouldn't be a good idea because they'd overhang the bore a little bit. The regular 350 gaskets are like 4.130 bore, and that leaves a lot of, you lose a little bit of compression right that way. With this one, it's got the smaller bore for like a 305 engine. It's a great gasket, multi-layer steel. You know, Harmonic makes some great stuff. I'm going to get these put on, get the head set on there. I'm using ARP bolts to put the heads on, and once we get that done, we'll start getting the intake done and get the distributor stuff put in. And you want to make sure your block deck is clean and dry when you put these on there. And that your cylinder heads on the bottom are clean and dry. Cast iron heads are so heavy. And I always stick a bolt in there. Okay, so on a small block Chevrolet stock block, pretty much every bolt hole goes into a water jacket. So what you want to do is you want to put a little bit of thread sealant, and I'm using the ARP thread sealer. Put a little bit of thread sealant on each bolt, and then I'm also going to put some ARP lube on each bolt to make sure that I've got enough lube on there to get the torque value right. I put the lube close to the bottom, and I put the thread sealer on top. That way it gets it lubricates going in and then seals behind it. Okay, so now I'm going to torque these, and at 65 is where I need to go. I'm going to torque it in 2 steps. So I'll torque it to 40. I'm going to start in the center, and I'm going to go out like that in a pattern. So. Okay, it is time to put the lifters in. First thing I'm going to do is I'm going to put some of this comp cam lube down in all the lifter bores to make sure I've got plenty touching the crank or the camshaft. Alright, now my camshaft ought to have plenty on it. And now I'm going to take the lifters and I have not soaked these lifters or anything. I don't believe in doing that, and definitely don't put oil in them and pump them up. Okay, so for this build, I'm going to be using Comp Cam's roller tip rockers. Now, I could have went with a full roller rocker because these aren't really cheap, but they're really high quality. Now, they've got a longer slot on the ball, and it comes with stickers, which is cool. I like stickers. Now, it comes with a longer slot on the bottom of the rocker, so a stock rocker will probably have probably bind up on this size cam because this is 480 lift, and it's got a roller tip, so that's pretty cool. It's still a high quality rocker. It's a high performance rocker. It comes with a ball pivot like stock rockers, and it comes with a regular locking nut instead of a pilot lock like your stock rockers. It's pretty much a bolt-in. It fits the studs when they haven't been machined down for screw-in studs, so it's going to clear just fine like my old ones didn't. And like I said, it's easy to install. You don't need guide plates, any of that stuff. So I'll put a link in the description if you guys want these. They're great for, you know, 480 lift cams, something like that. Even 500 lift. I think they're good for like a little over 500 lift. I'm not sure. I have to look at it again. But anyway, Comp Cam's roller tip rocker, good quality piece. Now I'm going to show you how to put it on. Okay, so there are lots of different styles and methods how people want to have the camshaft turned when they adjust the valves. I'm going by the comp instructions. This is usually about the way I do it anyway, so it's not too far of a different thing. It's a very safe way. Like I said, there's some alternate ways to do it, and there's nothing wrong with those, but if you're new at this, then you want to follow the instructions until you know a little bit more about it and you can adjust it confidently some other method. Now, what the instructions say to do is to start with number 1 cylinder, and you want to turn the engine over until the exhaust valve just starts to move. As soon as the exhaust valve just starts to move, well, the exhaust lifter, because that's the exhaust valve actuator. So as soon as the exhaust lifter starts to move, adjust the intake. Now what you want to do, okay, well I had it right there where the exhaust valve just started to move. So now we're going to adjust the intake. You've got your push rod in here and it moves up and down. You've got some clearance there. What you want to do is you want to tighten your nut on your rocker arm until you get all the clearance out of there. Now one thing you'll see a lot of people do, and this is a mistake in my opinion, and I've seen some pros do this, and I don't doubt that they're setting it right, but if they're explaining it to you, they're leaving one step out that could be crucial in you getting this right. When you check your clearance, a lot of guys will leave the ratchet sitting right here. Well, if you do that and you're not paying attention, or you don't know what you're not aware it can happen, the socket will push down on the rocker arm and it'll change the amount of play that you have. It's real easy for that socket to go in there and push down on it, and you think you've got 0 lash when you don't. So what I'll do is I'll turn it a little bit, take the socket out, and I'll check my lash. Turn it a little bit, take the socket out, and I'll check my lash. And like I said, it's because you can get in here and you can push on it, and I've got 0 lash right there because I've got the socket pushed on the rocker arm. And now I've got movable, it's movable. So you just make sure when you're checking that your push rod is actually moving up and down still, you've got the socket off of the nut. It's not a big deal. Turn it a little bit. All right, I'm still getting a little bit of play up and down. All right, and right there it stopped. And I mean, it was probably a 1/12 of a turn or so. It wasn't very much at all. And the rocker arm will still move side to side. It just won't move up or down at all. And you've got a plunger in the lifter right there. that should be barely moving. If you can see that well, I can't because I'm getting old, but if you can see that well, if you got a light pointed in there, you can actually see the plunger starting to move down a little bit when you tighten this up, and then you can check it. But you always need to check to make sure that you've got zero lash. And see, I can still spin this push rod. Some guys will tell you until this push rod stops spinning. That's a terrible idea. Now, so I've got I've got it at zero lash, and now what I want to do is adjust it for the preload. Now, on a 3/8 24 thread stud like this is, every whole turn of the nut is going to move down 42 thousandths, approximately 42 thousandths of an inch. Comp Cams will tell you in their instructions or on their website that the ideal preload for the hydraulic lifters is 30 thousandths plus or minus 10 thousandths. So that's a pretty big range. 20 thousandths to 40 thousandths is the range. If you want to be right in the middle, well, if a whole turn is 42 thousandths, then half a turn is going to be 21 thousandths. So I'm going to go half a turn and go a tad bit more because I don't want to be at the bottom of my range. I'd rather be in the middle of the range. So even though the instructions do tell you to turn it half a turn, they're probably assuming that most people are going to set, when they actually get the push rod to stop, they're going to get just a little bit past zero lash, and they'll already have a few thousandths of, have the push rod down a few thousandths. So I'm assuming that's why they tell you half a turn, when half a turn is going to be at the bottom of the range that they suggest. So I'm going to go half a turn on this, just like that, and then maybe a eighth of a turn more, and that one's done. It's adjusted. Okay, and the next step is to turn the engine over until the intake lifter now comes up and is almost all the way back down. So I'm going to wait for my intake lifter to start to come up, and there it goes. And when it starts to come back, almost all the way back down right there, it's not all the way down, but it's close. Now I'm going to adjust my exhaust rocker arm. And I'm going to use pretty much the same thing. I'm going to tighten that up a little bit. Wow, I got it close on that one. Okay. All right. And I'm grabbing the push rod lightly, and I'm pushing up and down. And you want to make sure that you're not pushing the plunger in, because if you grab it hard enough and push down, you can still push it down some, you know, if it's all the way at the bottom, because it's a hydraulic lifter and they're not pumped up. So, all right, now I've got it to zero. I'm going to turn it half a turn and then plus a little bit. And we should be, I don't know, 25 to 28 thousandths. That little bit is an eighth of a turn. I probably could do the math, but I'm not going to. All right, so now you've got that done. And you go from cylinder to cylinder, doing it the same way. There's a couple of different orders you can do the cylinder in. You can do it in the firing order. You start with number 1, then go to number 8, then go to number 4, then go to number 3. You know, it's 1, 8, 4, 3, 6, 5, 7, and 2 is your firing order on a small block Chevrolet, unless you've had a 4-7 cam swap or something like that. But you can go through the firing order that way, or you can go down each bank. You're going to be spinning the engine over a lot. If it's a new engine, make sure you got a little bit of oil in your cylinders, because you're going to be spinning it a bunch to set the valves. Okay, on a small block Chevrolet, there are 4 gaskets. Your 2 gaskets that actually go over the intake ports and the water jackets and go about like this. And then you have these 2 gaskets, and they're made to go in the garbage can, unless you want an oil leak, and you could totally do that. Now, instead of using those, because those go on the front and rear China walls, and if you don't know why they call it China wall, you need a history lesson, because it's a big wall. Anyway, first thing you want to do before you get ready to put the intake on, you want to make sure your intake is nice and clean, and then you want to take some good RTV, not the blue stuff, man, it looks awful, but take some good RTV. I like using Ultra Black by Permatex, and you want to put a 1/4 inch bead of RTV, which happens to stand for room temperature vulcanizing. You want to put that across the rear China wall. And you probably want to do a better job than I did of making it neat and clean, because you don't want it down in your engine. Okay, so you want to put a 1/4 inch bead of RTV across the front and the rear wall and do a cleaner job that I'm doing. And then I put a little bit around the water jackets, just a little bit, to hold the gasket on, the front and rear. And then I kind of smear that around a little bit. Now you want to let this stuff set up a little bit because it's room temperature vulcanizing, so you want to let it set for 4 or 5 minutes. You want to take your intake gasket, make sure you got the right side going up, and set those lined up on your bolt holes. Sometimes you have to put a bolt or two in there, but I usually can get them to stick without doing that. And you can slide them up and down while you're putting the intake on also. Okay, now that I've let that sit up about 4 or 5 minutes, I'm going to take my newly painted intake. I'm going to set it down on here as straight as possible. Try not to move my gaskets. And it's going to push out the RTV, hopefully. Now when you do this, you want to have your bolts ready right beside you, ready to go in and line everything up. So we've got it set on there, and it pushed my RTV out just right, just like I wanted it to. If it didn't push it out a little bit, you probably didn't put enough on there. Now let me grab some bolts and put those in. All right. Get a little 12-point intake bolts in here. Make sure I'm ringing the holes on the gasket. Now these 2 bolts I'm putting in here go into the water jacket. The 2 center bolts don't. The 2 end bolt, all 4 end bolts do. 2 on each end go into the water jacket. So I'm going to have to put some sealant on these, but for right now I'm just going to get them in there and get the bolt started, and then I'll take them back out and put some sealant on them. So you don't want those leaking back up and getting water in the intake and you don't know why. Okay, now you want to tighten these from the inside going out, and I'll tighten the inside bolts on both sides first, and then I'll make my way to the back bolts. And like I said, I've got to take those out real quick and put some thread sealant on those bolts because they go into a water passage. Now I've got my thread sealer on these and can tighten those up. Now I've got my last 2 to tighten. It has the RT or the thread sealer on them. And now I want to go back and check my 2 center ones on this side. And do a quick run around of all of them around. Make sure they stay tight. Then I want to take my camera and I'm going to show you that you want to make sure all the RTV has made contact all the way around, and it has. It's a little thin right there, but it should be okay. And on the back, it pushed out all the way across on the back, so it should be fine. Okay guys, so the 307 is put together and ready to run. Well, not really ready to run, but it's close. It needs a carburetor, water pump, whatever, you know. Now, I'm building a test stand to put this engine on. I'm going to crank it up. I'm going to break in the cam, set the timing and all that on there, make sure I don't have any drastic oil leaks or big holes in the side of it or something like that before I put it in a car. And then we're going to go to the chassis dyno, see what it runs. And we might go to the drag strip before we go to the chassis dyno. Craig actually started painting the dart. It's going to look amazing. But anyway, so that's kind of throwing us off schedule a little bit. I'm still working on the 69 Nova, but it's coming along. Apparently it's really hard to get a trunk pan right now. Who knew, right? Everything is on back order everywhere for anyone, just the way it is. Anyway, subscribe, give me a like on the video, leave a comment. See you next time.